Hey all, welcome back. In today's video, we're going to start talking about systems of equations and how to solve them by graphing. But first, let's take a second to actually talk about what a system of equations is. So a system of equations essentially is when we're talking about more than one line. So when we say the word system, we're talking about a problem or a scenario that involves more than one equation of a straight line. So when we're talking about a graph, if I mention the word system, that tells me that I'm working with two or more lines at the same time. So system is basically, here's one equal line, here's another. As long as I have two or more lines on the graph or written in an equation, so a lot of times, let me just randomly write two equations here. I'll write something like y equals 2x plus 1 and y equals 5x minus 2. These are just two random equations. If I see two or more equations, this is also a system. Is it limited to two? No. I can do a system with three equations. Most of the time in Algebra 1, we focus on systems with two equations, but we can definitely push this a little further and write a system that has three equations and so on. You can also look, I can add even more from here. I can add another line down here. Okay? So that's what a system is. A system in algebra is a problem or scenario where we have more than one equation that we're working with at the same time. We're working with at least two equations, at least two lines, and that's what a system is. So there's different ways that we can solve systems. There's actually multiple ways, and that's what we're going to get into with these videos. In this video in particular, we're going to look at the first method of how to solve something like this, which is solving by graphing a system of equations. And then later on, we're going to get into the elimination method and the substitution method. So in this video particularly though, we're only focused on how to solve this system or system of equations by graphing. So before we actually begin, we're going to go back to our graph here, and let's talk about really quick what we're looking for in terms of when we're graphing these. So in order to actually solve a system of equations, what we need to do is we'll have two lines that we're given or that we have to graph. They'll give me two equations and they tell me to graph them. So I'm just going to draw two random lines right here, one in blue, one in red. And what we're essentially looking for is the solution to a system of equations is a point that is found on both or every single one of the lines in that system. So I'm looking for a point where both of these lines, that's on both of these lines. And that point is usually or always the point where they cross. So if I see here, the solution to this system would be this point where these two cross. So most often when we're graphing these, the answer that they're asking for when they say find the solution to a system, they're looking for the point where these two lines cross, okay? And that's essentially what we're going to do on these next two problems. We're going to go ahead and we're going to graph. So here I have two different systems. We'll call it system A, and over here we got system B. So we're going to work with one of them at a time. Let's go ahead and start with system A. I got y equals 1/2 x minus 2 and y equals 3x minus 7. Now the instructions say use a graph to solve each of the system of equations. So we're going to use these graphs that are underneath them. So that, like I mentioned, the first one I'm looking at is A. Now these are written in slope-intercept form, so I'm going to graph them. If you don't know how to do that, you might want to check out that video. It's also on this channel. How to graph an equation in slope-intercept form, but hopefully you're already familiar with this and know how to do this. So we're going to go ahead and we're going to start with the top line. I'm going to graph that one in blue. So -2 is my y-intercept, so I'm going to start on -2 down here. So I'm going to put a dot there on the y-axis, -2. And my slope is 1/2, which if you remember rise over run, that's what our slope is. This slope is telling me to go up 1 unit, to the right 2 units. So I'm going to go here, I'm going to go up 1 space, to the right 2 spaces, there's my dot, up 1, to the right 2. And I can do this, a lot of times when we're working with systems, I recommend doing more than just one dot, just so that you get a clearer line and a more accurate line. This will help you when you're drawing it as well. So I can go down one to the left too as well. And then I'm just connecting these dots. So there's my first line. And I'll go ahead and I'll label it. This is y equals 1/2 x minus 2. Now let's go ahead and graph this second line here. We got y equals 3x minus 7. So I'm going to go down to -7. That's down here. And the slope of 3 means go up 3 spaces to the right 1 space. So I'm going to go up 3, 1, 2, 3 to the right 1. That's my new dot. I can keep going. I can kind of already see, I've already mapped out where they're going to cross, but that's okay. We're going to go ahead and we're going to continue this pattern as much as we can. And then we're going to go ahead and we're going to connect these dots. And this was the equation y equals 3x minus 7. So I'm looking for the solution. Where do these two lines cross? They cross each other here. And this is the point 2, -1. So that means my answer, or the solution to this system, would be 2, -1. And that's how we solve these. We graph them. This is how we solve a system, by graphing. Okay, there's algebraic ways to do this as well, but we'll get into that later. Let's go ahead and let's sort of repeat the same process. Let's try this next problem. Let's try system B. Okay, so again, we're going to graph this top one here in blue. We got y equals 2x plus 10. So plus 10 would be right here. So I'm going to go ahead. Got plus 10. Now I can't really follow this slope. I can't go up 2 spaces and to the right one. Here I'm going to have to go down 2 spaces to the left one. So again, if you're kind of confused on why we're doing this, you might want to watch that slope, how to graph lines in slope intercept form. Also, you can also use tools like Desmos, which is a great graphing resource in case you're having trouble. Desmos.com, they provide a free graphing calculator. So there's our, this was y equals 2x plus 10 line. Okay, so now let's go ahead, line underneath. Y equals -1/4 x plus 1, so we're looking at a y-intercept of +1, which is right there. So we're going to put a dot there, and this slope is -1/4, so we're going to go down 1 to the right 4 spaces. Whoops, down 1 to the right 4, down 1 to the right 4, or we can go up 1 to the left 4. And there's going to be where they cross. Okay, I can go ahead again, I can graph this connecting the points. And this would be my y equals -1/4 x plus 1. So now we look to see where do they cross. They cross each other right here, which this is the point -4, (2). So the solution to this system of equations would be -4, (2). Now in reality, there's 3 things that can happen. Either the solution to our system is going to be a point, but there's also a chance that we get no solutions and infinitely many solutions. So before I actually show you what those look like, I just wanted to sort of talk about what they would mean and how could something be infinitely many solutions. Well, if one point, remember the solution to a system is basically finding a point that's on both of these lines. Okay, if we have 2 or more lines, we have to find one point that's on 2 or more of those lines. Okay, in order for it to be a solution, it has to be on all the lines that are in that system. So when we're dealing with 2 lines, we find where do they cross? Oh, that point where they cross, that's the only point that's on both of those lines. So that has to be the solution. how could I get something like infinitely many solutions? Well, infinitely many solutions would be if one line was right on top of the other. Essentially, two lines that are the exact same lines, alright? So if one line's on top of the other, that's how we get infinitely many. In order for us to get something like no solutions, we would be looking at something where we have lines that never touch. And in algebra, we learned that lines that never touch are actually parallel lines. So the only way to get no solutions would be that if they give us a system of equations that has two lines that don't touch. And this right here is essentially what all three of those examples would look like. So here I have an example of one where there's just one solution. That's the very first one, where the lines cross once and that one point is the only point that's on both of those lines. In the purple here, now you'll notice the reason why it's purple is because when we combine red and blue, we get purple. So essentially this is representing two lines. There's actually two lines here in the purple. This is two lines overlapping, which is why it is infinitely many solutions. Now, if these lines never cross each other, we don't have any solution because there's not a single point in this system where that point would be on both of these lines. And these are all three different scenarios. So the way I would figure this out is the same way we did those previous two problems. Okay, nothing would change. I would still graph two, and if I see that those two are overlapping, infinitely many solutions. If I graph two lines and they're never touching, they're parallel, there's no solution. And that's how we solve systems of equations, by graphing. So hopefully now you feel like you understand what a system of equations is and how you could solve it by graphing. Now, try it out on your own. You know, the best thing to do in math is to practice these things on your own. So I hope you go out to do that. And if nothing else, well then thank you for watching, and I hope you continue to watch the other videos. Like I said, stay tuned because we're going to talk about how we can solve systems by using the elimination method and the substitution method. Thanks for watching. I'll see you guys next time.